Hello and welcome to my lecture review for the textbook, Internet and Web Application Security 3rd edition. This is done by Jones and Bartlett Learning. Again, copyright, they own everything. This is their book. I'm using their PowerPoints. I'm just providing video lectures for my courses that are using their official book. The assumption is you own the book and you are in one of my assigned courses. The book ISBN number 9781284206166. Again, copyright for the Internet and Web Application Security 3rd edition by Jones and Bartlett Learning is owned and maintained by them. These are just video lectures on their official PowerPoints, so let's jump on in. Chapter 10, Performing a Website Vulnerability and Security Assessment. So this is interesting because oftentimes we forget that we do need to test things. So the main objective for this module is to explain the value and importance of vulnerability and security assessments for web apps, not just assuming they are secure. Key concepts. We're going to be looking at the differences between software testing and website vulnerability assessments. We're going to be looking at how to perform the initial discovery on a target, how to identify vulnerabilities and perform a vulnerability and security assessment, how to prep for a vulnerability and security assessment report, and look at the best practices for website vulnerability and security assessment. So, oftentimes we look at, well, we did a software test. They're not always the same thing. Software testing is a much broader set of procedure than a website security assessment. Software testing is testing the underlying software, not testing all of the web components. In many cases, including an assessment of a website security as a subset of the overall testing procedure. Software testing often includes at least checking the application. Meets the initial design requirements, operates as expected without errors, can be implemented so that it doesn't cause issues with applications, things like that. We're not testing the overall security of the web app, and that is why we have to do more than just a software test. So, before we get too much into this, we need to at least talk about the main components. So the website's first component will be the web server software, such as IIS or Apache. It's the actual hosting server software. There will be hardware, and that will be the operating system, it will be the physical server, and everything that the web server sits on top of. So for a Windows environment, it might be Windows Server 2019 or Server 2022. And then on top of that might be Microsoft's IIS or Apache. So those are the first two elements. There will also be software application that is used with the web server to collect and distribute information. And lastly, a database that will store the information being used by the application and or by the web server. So now that we at least understand the structure, we can figure out how to go from there. So performing an initial discovery on a target, we need to first understand what website we're going after, and do we have permission? So the website assessment needs to identify the components that will make up the website that will be tested. They need to verify permission, to verify scope. Discover activities also refer to fingerprinting and enumeration, and this will be used to identify and list various components of the web platform that will be targeted. Again, you have to have permission. Information might be looking at the IP address of the web platform, operating system versions, service versions, protocol versions, operating system, and any known published vulnerabilities about either the services, applications, or the operating system that all of that sits on top of. So again, we're going to collect a lot of information to see how we can best proceed. Again, one of the large stressors that have to be here is you have to have permission. If you are trying to footprint or enumerate or do any type of reconnaissance on a web asset, you need to have the permission of the owner or an authorized representative because, again, you're going to be using resources against that web server, and there's a whole bunch of legality at this point. Again, anytime you're looking at discovery or basic recon, you need to have permission. Alright, so now that we have that component out of the way, how are some ways for us to do some basic recon? So ping. Ping is a great way of doing this. So you could do a ping sweep. Ping is a utility designed to send a packet to an IP address and to determine if it's active or not. And that's not 100% correct. So if we open up a terminal and we ping google.com, it resolves the domain name to an IP address, and then it sends for ICMP echo request packets. So it's a utility designed to send an ICMP echo request packet to either an IP address or a domain name that will be resolved to an IP address to see if it is active and if it is responding to ICMP traffic. ICMP and ping are essentially the same thing. ICMP is the protocol that the utility ping uses. The ping command is typically executed against a single IP address. A ping sweep can actually run against a range of addresses. Ping sweep can also be called a host discovery. Some of the ping sweep utilities in Windows or in Linux. In Linux, Nmap is one of the big ones, or hping. Those are the two big tools. In Windows, you have IP address tracker, you have Superscan, you have Zinmap. Zinmap is just a graphical version of Nmap. You have IP Advanced Scanner, and so forth. The nice thing is, point here is there are tools. Here's an example of the Superscan ping suite. You put in the address, the host name, URL, or whatever it is, and you can find details. Now, this is an old screenshot from an older software, but it's still relevant. It grabs information and it grabs the details from a domain. So Nmap is a network mapping tool. The focus or functionality is a ping sweep, port scan, and OS detection. The standard Nmap scan performs a non-intrusive activity, and it's unlikely to impact network services against like a server or network router or switch. However, if you're doing an Nmap scan against an industrial network, sometimes that Nmap scan can actually overload industrial controllers and get them to stop functioning. Again, that's one of the key things with getting permission before you do anything. So Nmap again tries to do a basic ping operation, whether it's an IP address, seeing it's up, active, alive, time. It could be looking at resolving MAC addresses, and what are the communication status of the ports? Are they open, active, closed, inactive? And the status of the more 1,000 common TCP ports. Looking at just a basic scan, nothing super in-depth, but Nmap you can fully customize to do whatever you need it to do. Alright, so graphical version of Nmap is Zinmap, and again, you'll notice, actually I'm going to grab my pen real quick. The command will use an Nmap command, and you can just change graphically the profile type, and that will then, depending on the profile type, change the command that you use. And from there, it will execute based off of your target. I'm going to erase all this. This would be your IP address or your domain. And then down here will be your actual output. And then you can see things like ports and hosts and topology and more details. So this is a nice graphical version of Nmap. So we talked about fingerprinting earlier, and we talked about being able to scan tools. So Nmap does have a TAC-O option, and that's to identify the operating system. If you know the operating system is Ubuntu or Windows Server, then you can then tailor your information gathering for a specific operating system. So identifying the OS running on the hardware so that you can then understand the applications that are running on top of it. The big two tools are Nmap and Nessus. And in reality, Nessus is pretty expensive, so Nmap is the typical go-to tool for OS fingerprinting. And it's part of the regular scan profile within Nmap. So you might get something like this. So if you run it against a target, you might get, its Linux version something or Windows version something. But it tries to identify the operating system. Nessus does have a vulnerability and port scanner built in, and a lot of the features do overlap. Nessus is complementary to Nmap, but Nessus is expensive. So, composed of two components, a scanning engine and thousands of plugins that's associated with vulnerabilities. To scan a system, users create a policy. They choose the options and the plugins, and then they run it against a target, or against the policy. Has the ability to perform both authenticated and unauthenticated scans. Authenticated scans require permissions to log into a target system, where unauthenticated is the default, and it's just a basic scan with no login credentials. So here's an example of Nessus, and then we can see the target and we can see the vulnerabilities. So performing a vulnerability and security assessment, typically single server websites consist of a web server, web app, a web server front end, and website forms. The forms are going to be the static individual web pages used to capture input. So they'll have input, forms, and things like that to gather data from the users. The front end is typically the web server software that presents the website. The server application is the actual application that's collecting, using, and or providing data. So web server OSs, typically we will identify the OS type and version, the service packs and patches, the active services and or ports that are supported by that operating system, and the ones that are open and listening, and any known vulnerabilities associated with any of the components. That way you can better target your victim. So typical enumeration and assessment would follow if the IP address of the web server is unknown, or if it's multiple web servers. Then you're going to run Nmap with a quick scan for an entire IP range, or based off of the domain name. Ports 80 and 443 should indicate the web services or web servers that are running, and then we could run our vulnerability scan against the IP addresses that are using those ports. This should produce a report that includes information about the OS and any vulnerabilities. If a privileged credential scans are available for the OS, such as Windows admin equivalent login or Unix root equivalent, it is recommended to do these types of vulnerability scans. You'll get more detail. However, it's not always realistic, and it also depends on the scanner. So manually reviewing the available services that are enabled on the web server so that you can then determine if they're necessary or what they're doing, and then open or close as required. Typically, unnecessary services should be turned off. So additional items is looking at insecure SNMP configurations, weak passwords, or services that are either out of date or allowing remote connectivity should be reviewed to see if they should stay on. Big thing here is when you run your vulnerability, you want to be checking to see everything that is open, active, and responding, are they necessary? Can we, at a certain point, pause them, disable them, or stop them if they're not providing something that is necessary? Alright, moving past that is our web applications. Web server apps can be anything from a group of scripts to custom code program. It really just depends. In a lot of cases, assessing web server apps consists of scanning the application for known vulnerabilities, poor coding, and things like that. This performs a specific test for the coding itself. Tools like Nessus or Metasploit may be useful in finding and testing vulnerabilities in web apps. There's a lot of built-in tools for both Nessus and Metasploit, so finding holes are kind of what they're known for. Recommended that code be reviewed by a commercial source code assessment tool, such as WebInspect or IBM Rational App Scan. Again, this is just kind of dependent on how far you want to go. Most organizations are not going this far. Source code tools examine various programming languages and find poorly designed or insecure coding. Because secure coding is a real thing, though a lot of programmers don't always think about the security of the code that they are writing. Techniques that could also represent a risk could be the ability to circumvent the application's authentication process or controls, code or command injection that forces an application to perform certain functions or perform in a certain manner, or manipulating the URL for data input fields to traverse data directories or at the application itself. You can manipulate the web app to do things, and if that's the case, we probably need to harden it a little bit more to make sure it's secure. Recommended performing both authenticated and unauthenticated testing for the web apps. This will identify potential risks that might be exploited, either or. Typical steps would include identifying the type of app that is running on the web server. Is it SharePoint? Is it email? Is it form-based? Is it a front-end database? Back-end database? What? Research the app to determine the types of code or script that could be there. Is it C? Is it C++? Is it C#? Is it Java? Is it a variation? Then select the appropriate utility to run against the web app or scripts, such as in Stalker, to see if there are any known vulnerabilities in the web application. Alright, let's talk about the web front end. Common activities performed when assessing a website front end. So this normally means identifying the type of front end website. Is it IIS? Is it Apache? What app is the user going to be interacting with that will be serving whatever form or web page that is there? Determine the function of that front-end software. Is it just HTML pages? Is it data input-output? Is there access to sensitive files or data or to a backend database? What? To do that, we're going to run a web server security utility like Nessus or Instock or something like that to identify the contents. In addition to looking for basic vulnerabilities, the scanners should also be looking for basic OWASP threats like cross-site scripting attacks. You can also use tools like HTTrack, Website Copier to crawl or scan the website pages for hidden fields, hidden data, things like that, or just a general website crawler to see what's available. Because oftentimes, web designers will create a web page or web app and then leave a lot of old miscellaneous data there, old items there, and it becomes vulnerable because of all of the old content that is still accessible, even though they thought that the data wouldn't be accessible. Another set of things is using HTTrack to provide information about the directory structure, because sometimes if you can clone the site, you can take a complete online copy and bring an offline copy, thus being able to do more directory transversal based attacks. You can use Google resources or Google advanced search commands like dorking to see if there's any additional examples. Like you can do SSN and you can choose a specific site. Or you can look for a specific file type and a specific site. Again, all of that's called dorking to be a little more specific in your advanced searching. So website forms and user input, that's typically going to be the website that the user is interacting with. And if there's any user input or user boxes there that may not look at data correctly. For example, if you did a search box, can I type in a string of SQL code and have it executed? Or is it just going to take it as a search string and only search? That's what I mean by having the code checked, verified, and look through it. Again, entering a very large number of characters into a field that is expected only a few, what happens? Properly configured or well-written website app would require correct number of characters and formatting. So again, it really just depends on what you're trying to accomplish and how you're trying to accomplish it. For example, if I have a login user section and I don't check to see if it's a proper email, that might be able to be exploited. So improperly formatted data would involve entering special commands into a field. This sometimes is known as a code injection, or it could also be known as a cross-site scripting-based attack. Most vulnerability scanners can perform basic scans for code injection vulnerabilities and XSS vulnerabilities, thus kind of looking for them a little easier and making websites less vulnerable to them because, again, they're going to be scanned regularly, so more organizations should already have these mitigated, because if they are known and they are checked regularly, then current sites should not be vulnerable to them. And some are and some are not. So now we have to talk about some basic compliance, like our PCI DSS. PCI DSS stands for Payment Card Industry Data Security Standards. What's really interesting here is they write the standards for websites that store, transmit, or process credit card data or payment card data. Failure to comply results in losing the right to process payment cards. So following PCI DSS requirements are most related to performing vulnerability and security assessments are requirements 2 and 6. Vendors supply default passwords and secure systems and applications. What's really funny is we keep saying things like, oh, well, you should make sure you're not using the default supplied credentials. But organizations are caught doing this all the time. That's why it's still a requirement that we check for them being ran, because this happens quite often. The following PCI DSS requirements are most related to performing a vulnerability and scan. It would be requirement 11, testing systems and the processes. This requirement contains the mandate that web apps and systems be regularly scanned for vulnerabilities from inside the network and where the server sits from the internet. Regular scanning. Using a planned attack to identify vulnerabilities. Normally, if you're doing recon, you're developing a plan. So you do want to at least get a basic plan together so you know how to target and identify the different vulnerabilities. So, general process is develop a plan of attack, identify the gaps and holes, attempt to realize the threat. Developing a plan of attack starts with basic recon. What are the target? What are the OSs? What are the IP addresses? What are the ports? What are the services? What are the service versions? And from there, that can be used to identify the gaps and holes. The web front end, again, looking at the attack plan. It could be looking at the application user's interface. How the website visitors, regardless if they're legitimate or not, gain access to the data. Is there a process to gaining access to the data? A basic planned attack to a website front end might include the strategy, attacking the input fields or the forms, looking at the system's website and the different techniques, could be putting invalid data into fields and attack authenticated forms in a way to see what you can find, or attempt to do a buffer overflow to see if you can gain access to the web portal or in a authenticated area. So web front end, identifying gaps and holes. Again, that would be looking at the OS, looking at the services, looking at the patches, looking at the configuration settings if feasible. These pieces of information provide insight for gaps and holes. Review source code in hidden fields if possible. Escalate privilege or realize an attack. Exploiting vulnerabilities or flaws to gain access to resources. Again, that's also sometimes referred to as realizing a threat. Because you might have a threat, but if it's never found out or never actually exploited, then is it really a threat? It's a possible threat, but until someone actually does something with it, it's hard to say that it's an actual threat. Scenarios used to test horizontal escalating privileges. Again, looking for web page pages with documents stored in secured areas. This is a sign of potential vulnerabilities, so you might look at different scanning tools or crawling tools. Looking at backend systems like an SQL database. Backend systems are also subject to not being set up correctly or even securely, because the backend databases of a web app solution typically do not offer the same variety of services than the front end does. Planned attacks could be easier. Strategies for attempting the backend are relatively the same though. The intention is to gain access to the data through compromising a system, a service, or something to escalate privileges to gain access to an area that you typically wouldn't or shouldn't have access to. The backend develop an attack plan. Developing the attack plan for the backend is similar to one of the front end. Many attack methods can be performed through the same web app or form for both the front and back end. Differences in planning an attack on a database could be that additional discovery tools are needed to identify the different types of database. Is it an SQL? Is it a non-SQL? Is it a Mongo? Is it any other variation of database? Once the database is identified, general plan of attack on the database might attempt to follow these steps. Access or retrieve data by injecting data into a field or form. Access or retrieve data by gaining privileged access. Try to gain privileged access. Lastly, crash the database to gain privileged access through other portions of the system. This may not always be the best option, but it's definitely a workable option. Identify the gaps and holes for the back end. Probing the database app for gaps and holes are commonly used for pen testing. Metasploit has a lot of free built-in tools for doing just that. Though it's not as user-friendly, there are lots of resources that kind of help you along. Web app scanners also have scripts and tests for back-end databases, so you're not always just left by yourself. Escalate the privilege level. Again, attempt to gain access to the back end. The same strategies apply to front or back end. Metasploit has a lot of great tools for attempting various strategies for escalating privileges for a web app for both the front and back end. Though, caution, a lot of scripts and techniques used to gain access involve strategies to either crash the app or the database or the web server. So again, you need to make sure you have permission before you start just doing whatever you want. So some ways to do some of this would be performing an SQL injection for data extraction. We already know that most scanning and pen test tools have built-in SQL injection testing capability. However, SQLIs is a fairly simple activity that an attacker can attempt manually by manipulating either the URL or a search engine or a search input box to see what goes on. The nice thing here is we know that these types of attacks have existed for years, and we're still struggling to secure them. SQL injections is the act of inserting various SQL commands in a URL or a form field or a search box to see if the command can be ran against the backend database. Oftentimes, if code is not done correctly, you can actually have SQL code put in a search box or a URL window and have it executed. So to contain a basic SQL injection attack, basically look for web pages that contain data entry fields for entering data, like a username, password, or search. These web pages, for the purpose, are typically not static HTML code, but are written in like ASP or ASP.NET or PHP, and these web pages will contain extensions like ASP or PHP or JSP in the string of characters. Let me grab my pen. Here we have index.asp. Here is a search query. Or here is a search query. And this might correspond to a text box asking for a login ID. Well, you can manipulate that. You could put in something and see if it brings back anything. By either manipulating the URL or entering data into these fields, you can now try some characters that have specialized meaning in SQL, like a quote, a double quote, double dashes. The single quote tells SQL to escape from the search criteria and back to the SQL statement. Knowing this, you can then enter data into the web page field to be injected as a part of an SQL statement. So you could do quote or 1 equals 1. This tells the statement to return data if a statement processes are true, because 1 always equals 1 and the statement is true and all the data is returned. This is a pretty simple attack, but it is still something that some websites are vulnerable to. So you cannot just assume that all websites are protected against this. To contain SQL, again, you have to check, verify. There's a lot of process here. The more advanced knowledge of SQL query formatting or server commands are necessary to get more creative. So you can create your own SQL injection. Basically, through any type of SQL command, you can insert into a text box or URL. The more SQL commands you know, the more that you can get creative. Or you can just use the built-in ones in Kali Linux or Metasploit that can just kind of do a lot of that for you, automate it through automation. Moving past that, preparing the vulnerability and security assessment report. So a big part of here is everyone goes, well, I want to do security, but I don't like reports. Well, a lot of what security analysts are doing is reports. You do a task, and you need to explain to other people how you did what you did and how to fix it. The reports are going to be crucial to this. Oftentimes I get asked, well, how do I become a pen tester? Well, pen testing is, 30-40% pen testing and a good 60% report writing. A lot of the skills you're going to have to do are develop your report writing ability. Looking at executive summaries, summary finding, the details of this vulnerability and the security assessments, and then remediation. It's not as good, oh, this is what I did. You need to be able to be specific. I was able to do this, this, and this. These are the vulnerabilities I found. This is how I did them. And here's how we can make sure they are fixed in the future. You can do a remediation. The executive summary should be the critical or high vulnerability gaps at a very high level. Information should be very specific and clear so that executives can quickly consume it. These are for management typically to make better business decisions. As we move past that, we have description of the systems and apps that were assessed, brief explanation of why, description of who, if there's third-party forensics, if there's any high-level other items that are really critical, and or risks that the executives or management need to know about. And again, typically a brief summary of remediation or remedies that are current or underway. Summary of findings that are a little bit more in depth, that are not typically for the executives, but gives the ability for the executives reading, if they want more detail, they have more detail. They outline most or all the findings rather than just the most critical ones. Again, this is going to be more detail, but not only targeting our executives. Percentage of quantity of the vulnerabilities found, vulnerability types and categories, website components, web app versus front end versus IP address. All of that is information that needs to be identified so that they can figure out how to remedy these. Percentage or quantity comparison of vulnerabilities by critical. How many are high? How many are low? How many are medium? We need to know what specifically are we looking at. If we said we had 1,000 vulnerabilities and only 2 are critical and 980 of them are very low, that doesn't do a lot of good for us. So we need detailed information. Because you might look at, oh, we have 1,000 vulnerabilities, we need to fix this. But if only 2 of them are critical, then that number is less important. You need to have a table or list of gaps that are confirmed. Text descriptions or observations about the quantities should also be shown. You need to have details of the vulnerability assessment. What are the CVEs? What are the CVSSs? What are the types of critical ratings? If you're looking at the security assessment, again, you're going to have details for that. This is typically more like the pen testing section. It will probably be less structured, but you're looking at what's happened, what's occurred, and you typically have a recommendation section for any gaps that were identified. That way, the organization knows how to better protect themselves. So, best practice is choosing the right tool. Test verified with permission. Normally, thinking outside the box is going to be really important. Research. Everything starts with research. You do your recon so that you can have information, so you can do more research, so that you can better target your system. But everything starts with research. Alright, that is it for this module. If you have any questions, thoughts, or concerns, definitely feel free to reach out, and thank you. Alright, that concludes this video lecture for this chapter. If there's any questions, thoughts, concerns, or issues, please don't hesitate. Feel free to reach out. Thank you.